Friends, hello everyone. This short video is dedicated, as you understand, to the CRISS CPM computer, or rather the new version, which has just arrived as of summer. Appeared and will soon be published in the July issue of Radio magazine. This version differs from the previous ones in exactly one way. What everyone has been waiting for has been added. Everyone really asked to add color. And finally this color appeared. CRISS CPM can now do this. Basic support for 8 colors is now included in the computer design. You can colorize the output. You can use colors in games. All this is compatible with the previous version. In this video I'll tell you a little about what it is and roughly how it works. Read the details in the July issue for 2023 of the magazine. Radio magazine. First of all, let's note that this is what computer. Externally the computer has not changed the form factor, the entire appearance remains absolutely the same. Carefully open the lid inside. A compact board on which all the main components are located. Let's take a closer look at this board, see what elements are installed on it and what is the difference from previous versions. So, here is the board of this computer. Nothing fundamentally has changed. Large microcontroller. From Mega 1284 performs the functions of a central processor plus a controller for some devices, in particular It works as a network interface controller. It is assembled here from a corner. The driver chip itself is not installed, but this is not scary, because the firmware is made in a universal way and now it itself determines what kind of hardware is installed on the dress and is needed. Loads the necessary interfaces and SD card. A microcircuit is located nearby. This is memory. This is a squeaker. Further, regarding the main components and elements of the computer, this means that this microcontroller from Mega 328 performs the functions of a controller for external devices. It services the keyboard. It handles serial I/O. The driver chip has moved a little compared to previous versions. Slightly to a different place, therefore, but the meaning remained exactly the same. This is in interface output res. That is, it receives an image from the central processor. The logic here is a little different. There is no direct access to memory. And at the time of recording video memory, the central processor duplicates it to the external device controller. External device controller is very fast. Processes this parcel, so there is practically no delay. At least compared to standard direct memory access schemes, performance is not degraded. Further, there is another microcontroller nearby, also from Mega 328, but it is already part of the video controller. In general, the video controller takes quite a large part on the board. First of all, this is our clock frequency generator. For VGA interface operations. Next, a small microcontroller from Tiny13 is responsible for generating clock pulses. But here is a large controller from Mega 328 and several elements of small logic, 1, 2, 3, they are responsible for generating the VGA output signal. Please note that we have 20 MHz microcontrollers, assembled a 25 MHz VGA video signal interface without overclocking and without any other violations of permissible operating limits. This was the same on previous versions of the computer. In addition, this means that it is not established here either, but nevertheless it is provided for. Real-time clock chip. Next to it is a slot for a backup battery. Here we install an internal ROM of 128 kilobytes in size, which allows you to save 2 user sessions and quickly return to them when switching modes and when starting a session. Another chip here is a device decoder on the internal system bus, the internal SPI system bus, operating primarily at a frequency of 5 MHz. This is quite enough to ensure good computer performance. It is similar in speed to computers. On a Z80 processor with a clock speed of 4 MHz, the central processing unit fully emulates the Z80 processor plus additional commands. This, as already mentioned, is a network interface. This is where the power amplifier chip is installed for built-in speaker. It is located on the top cover of the case. It was all there. The same thing happened in the previous one. The previous video talked about, there was a video about the 319 board and all this was described in great detail in the radio magazine. What's new on this board? First, the little things. It is now possible to install an optional volume control for the internal speaker. It is now possible to install DC power converters can now supply more than just the external 220 volts via modular AC-DC converters, but can also be assembled DC-DC converter and power the computer from 9 to 24 volts. An opportunity has arisen, an optional possibility of installing a power switch, which has also been requested for a long time, and has been done. From fundamental changes, for the sake of which all this was done, 2 new microcircuits appeared on the board. This is a new microcontroller from Tiny AE. 4-bit shift register. These 2 microcircuits perform the function. How to put it correctly, colorizers of the output video signal. To be compatible with all previous versions, the entire design has been made in such a way that the original VGA adapter has not been modified, but now its output goes to this combination of 2 elements. Microcircuits, and at the output you see this most beautiful picture that you observed at the beginning. You see the colored output control is integrated into the BIOS and all color management occurs transparently for the user via escape sequences. This is not an attribute schema. The scheme is made a little differently. Read how it was done in detail in the July issue of Radio Magazine. Actually, that's all. A short description of how this is done. The circuit works stably. For those who have already collected previous versions, please note that we have changed. Our VGA connector has changed. He has become narrow-minded. That is, in previous versions it was wide, but I had to sacrifice it. Still, 2 more microcircuits were added to the board, which was previously quite compact, plus 1 microcircuit increased greatly in size because the bus decoder became Now you can go to 16. Connect external devices. For this purpose, it is even possible to install a second board on the second floor. We'll talk about this in the next video, when we look at what expansion modules can be used here. That's all, actually. If you have any questions, the project website CRISS.radio.ru. Come in and look, all the information is there. You have the most detailed description exclusively in the radio magazine. Thank you. That's all. Goodbye.